For number 39, we're given an equation that's called Tschirnhausen's cubic, and they want us to find the area enclosed by the loop. So whenever you see the symbol, you're okay to use technology. So let's put it in our graphing calculator and see what it looks like. So this curve looks like this. Now, this is not a function because it does fail the vertical line test. So for us to make it a function, we're going to have to take the square root of both sides and then consider the positive and the negative root. So when we take the square root of both sides, we have a positive and a negative root. So we have, this is the positive root, and then we have the negative root here in green. Now, so we split it up into two and we say, okay, these are two different functions and that's fine, we can work with that. Now, instead of, since we want to find the area enclosed in this loop, instead of integrating first the positive root and then integrating the negative root, it's going to be quite cumbersome. What we're just going to do is we're going to take twice this curve over here in green, twice the area beneath it, right? Because if I take all this area over here and I double it, I'm going to get the area beneath these curves, right? So we're going to see the green line is actually the negative root because it begins positive and then goes all the way down. So we're going to take twice the integral of the negative root from -3 to 0. That's our boundaries. So we have that y squared is equal to x squared times x plus 3. So then when we take the square root here, we have that y is equal to the square root of x squared times the square root of x plus 3. So y is equal to x times the square root of x plus 3. And remember that we're taking the negative root, because the negative root ends up being our upper boundary from -3 to 0. So yeah, we're ready to set up our integral. This is the integral from -3 to 0. And remember that we're doing twice the integral, or else we would have to integrate the negative root and the positive root. So we're doing twice the integral of minus x times square root of x plus 3 dx. And now all I'm going to do is I'm going to take this negative, since it is a constant, I'm going to put it outside. So I'm just going to put it outside and remove it from the inside. Now to integrate this, we do have to make a u substitution. So we're going to say that u is equal to x plus 3. And because we have a lone x outside, we also need an expression in terms of x. So we'll just bring the 3 over to the other side. So then I have u minus 3 is equal to x. And lastly, I cannot forget my dx. So I have that du is equal to dx. And now we are ready to plug things in. So we have minus 2 times the integral from -3 to 0 of, whenever I have x, I'm going to put u minus 3. That is u minus 3 times the square root of u, which is x plus 3. So I'm just going to say that this is u to the 1/2, because then it's easier to integrate, and then times du. And then let me just distribute this u so that it's easier. So I have minus 2 times the integral from -3 to 0. U to the 1/2 times u is u to the 3/2 minus 3 times u to the 1/2 times du. Okay, we are ready to integrate. So this is -2 times the integral of u to the 3/2 is u to the 5/2 times 2/5, and then minus 3 times, that is u to the 3/2 times 2/3. So let's substitute back in our x plus 3, and we'll multiply this -2. So I have here -4/5. We'll substitute it, x plus 3 to the 5/2. And then I have, let's see, the 3's cancel out, and I'm multiplying with this negative 2. So plus 4 times x plus 3 to the 3 halves. And all of this evaluated from negative 3 to 0. So let's plug in our boundaries. Whenever we have 0, this is just going to be equal to negative 4 over 5. 0 plus 3 is just 3. 3 to the 5 halves. And then I'm going to have plus 4 times 0 plus 3 is just 3 to the 3 halves. And now there's no need to plug in the lower boundary, because if I plug in minus 3, I'm going to have minus 3 plus 3, which is 0. So the whole term disappears. Same thing with this other term. If I put in minus 3 for x, it disappears. So this is our answer. Now let's just simplify this. So let's see. I'm going to factor out 3 to the 1/2. So this is equal to 3 to the 1/2 times minus 4 over 5 times 3 times 3 to the 4 over 2 plus 4 times 3 to the 2 over 2. And when I clean this up, I have 3 to the 1/2 is root 3 times, let's see, 3 to the 4 over 2 is just 9 times minus 4 divided by 5 plus 4 times 3, which is equal to 24 over 5. And this is our answer. So let me just zoom out for you guys to see everything. And that is it.